This is number 2 for Related Rates AP FRQ review. So the inside of a funnel, height 10 inches, has a circular cross-section as shown in the figure. At height h, the radius of the funnel is given by r equals 1 over 20, parentheses 3 plus h squared. The units of r and h are in inches. Find the average value of the radius. So here's something that we have to, that's a little bit confusing, is that we're looking at this and trying to figure out how to fit this into a graph. Well, we need to treat this like we need to turn this diagram sideways to kind of see it that way. We can think of h as the x-axis and r as the y-axis, and we're trying to find out what is the average height, the average radius from one end to the next. Okay, so we're just kind of focusing on this portion here. So that's what we get when we turn our diagram sideways. So this is the average value theorem, which is 1 over b minus a, integral from a to b of the function. So in this case, our function is radius, with height being the independent variable, and we just go through our antiderivative step. We can approach power rule for both. We'll distribute the 1 over 20 first. Then we can go through power rule for both terms. Okay. And once we go through power rule for both terms, 3 over 20 becomes 3 over 20 times h squared over 20 becomes h cubed over 3 times 1 over 20. We can multiply the 110 through, and then we plug in our upper bound minus lower bound. Upper bound of 10 gets plugged in for all the top into the expression, minus the 0, which in this case will just leave us with 0. Multiply the 110 through, and we get our answer 109 over 60. Okay, part B, find the volume of this funnel. So volume, we need to think of this as this is rotating around this H line. So this is going to be a disk method problem. There's no gap between this x-axis and the shaded region. So once we rotate, we're going to get something that will resemble this funnel. Okay. All right. So we can do top minus bottom. Once we draw our radius, so top is the r of h, but the bottom is the 0. We can get that to be 1 over 20 times 3 plus h squared. So that's our radius. So now we plug into our formula. Our integral is from 0 to 10. So from 0 to 10, integral of r radius squared. And then we can expand this out, go through power rule for each term, plug in upper and lower bound, and that gets us to be 2209 over 40 pi, or 55.225 pi. Okay, part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid? So we're looking for dH dt, rate of change of height with respect to time. So this is a related rates problem that's going to show up for this part C. All right, so we start off with our radius equation. We can expand this out, and we can just go ahead and find the derivative with respect to time. So r is going to produce dr dt, h will be produce dH dt. So let's go through this process here. So r becomes dr dt. 3 over 20 is a constant. That constant will just go to 0. 1 over 20 becomes 1 over 20 times h squared, which is 2h, so 2h dH dt. And then we're just trying to solve for dH dt. We know height is 3 inches, so that plugs in for h. We know dr dt is negative 1/5, and then we just work this out. So this becomes 6 over 20. Divided by 6 over 20 is the same thing as multiplying by the reciprocal, so negative 1/5 times 20 over 6 reduces to be negative 2/3, and dH dt, the height is going to be decreasing at negative 2/3 inch per second.